Hi to all of you, I am Dr. Divya Joyce. Today we are going to see about the chronic complications of diabetes mellitus in continuation to our previous classes on diabetes mellitus. So, what are the complications of diabetes mellitus? So, we can see that the complications of diabetes mellitus include both vascular and non-vascular complications. Among the vascular complications, again you have microvascular and macrovascular complications. Microvascular meaning the small blood vessels in your body, like your capillaries, are getting involved by these pathogenic processes, and macrovascular meaning the medium and the large sized arteries are getting involved by these processes. Next we will see that all the complications in diabetes mellitus are primarily secondary to two main processes. One is the process of hyperglycemia, persistent increased glucose levels, which causes certain mechanisms which are going to lead to these complications, and the other one is that insulin resistance. Insulin resistance is always seen in type 2 diabetes mellitus. Though there is a sufficient amount of insulin, the body is not able to make use of this insulin, and hence there is a hyperglycemia. This insulin resistance in all the tissues of the body are not only going to cause type 2 diabetes mellitus, but multiple metabolic pathways are getting dysregulated because of insulin resistance. So this insulin resistance per se will cause certain complications. So totally both these factors contribute to the complications seen in diabetes mellitus. We will also see next about two giant trials which were done and which demonstrated a very important thing in diabetes called as the legacy effect or metabolic memory. So first one is the DCCT trial, diabetes control and complication prevention trial, and the other one is the UK prospective diabetic study trial. So these two trials, they took patients having similar HbA1c value or similar glucose values initially, and one group was subjected to an intensive control over years. We have along y-axis we have years, and along the x-axis we have their hyperglycemic state, their degree of high sugars. So if we see, one group was subjected to strict and intensive control over the years, and the other group at the starting point had the same sugars as the control group, but not a very strict control was maintained, leading to progressively increasing sugar levels over the years. Or finally, because of adequate control over the years, maybe they both met together at the same point. Whatever happens, if we control sugar levels in the same state without hyperglycemia being there for a long period of time, this group, the control group, had reduced incidence of complications. Whereas a group of people who had high sugar levels fluctuating, finally though they both attain the same sugar levels, this group will have an increased rate of complications. That is, the body is able to have a metabolic memory of whatever high sugar levels was there previously in the other group. So when we have a very good sugar control in the early years of diabetes mellitus, that leads to prevention of complications on the long run. This was demonstrated clearly by the DCCT trial and the UK PDS trial. So these two trials were important in proving the importance of high and adequate sugar control in both populations. Next we will see about genetics. So as we learnt about the pathogenesis of diabetes mellitus, we saw that genetics had a very important role to play in the development of diabetes mellitus. We will also see that genetics has an important role in determining people having the same adequate sugar control. Certain group will have increased risk of complications, whereas certain others will have a lower risk of complications. This will be determined by their genetics. So just like the disease, the complications also are dependent upon genetics of each individual. Mechanism of complications. So both high sugar values and insulin resistance are responsible for the complications. We will see what high sugar levels does to the body. One is it induces epigenetic changes. What are epigenetic changes? So these are changes that are done to the DNA, the coding machinery in our body, and these changes are done which cause certain downstream pathways, either activation or decrease or inhibition of downstream pathways, leading to certain changes in that particular individual. But though changes are made in the DNA, these are not inheritable. That is, they are not transmitted from one generation to another. These are called as epigenetic changes. Permanent changes are made in the DNA or the coding machinery of a human being. Advanced glycosylation end products. That is, you have proteins and lipids normally in our body. So whenever we have glucose in excess, this excess glucose combines with these proteins and lipids, causing formation of certain products called as advanced glycosylation end products. That is, glycosyl group or a carbohydrate moiety is added to protein or lipid, leading to production of advanced glycosylation end products. These advanced glycosylation end products cause activation of multiple pathways downstream, leading to the complications seen in diabetes mellitus. Sorbitol pathway. This high glucose that we normally have needs insulin to be metabolized along the regular pathway, along your Krebs, along your glycolysis cycle, along your TCA cycle. Everywhere we need the insulin for regular metabolism of glucose. Since insulin is absent or insulin resistance is there, this glucose is metabolized through alternate pathways. One is through your sorbitol pathway, increased amounts of sorbitol are produced. The other, which gets deposited in multiple tissues leading to the complications seen in diabetes mellitus, or the other one is through your diacyl glycerol formation. Diacyl glycerol is a second messenger, as we have learnt in the biochemistry. So this diacyl glycerol causes protein kinase activation and multiple downstream pathways leading to accumulation of cholesterol, multiple other end results which will lead to the complications. And other is activation of hexosamine pathway. This also leads to certain products getting deposited at multiple sites in the body, leading to the complication of diabetes mellitus. So mechanism of complications, one is epigenetic changes, formation of advanced glycosylation end products, and metabolism of glucose through alternate pathways leading to their accumulation at multiple sites and activation of different downstream pathways than it is normally. So microvascular complications and macrovascular complications we will see in detail next. Microvascular complications includes retinopathy, neuropathy and nephropathy.